Hello friends, this is Ralph, and in today's video I'm explaining the basics of the Behringer 1027 analog step sequencer and how to connect it to the Behringer 2600 semi-modular synthesizer, so stay tuned. The clocked sequential control module 1027 is part of the Behringer 2500 Eurorack modules. If you want to learn more about the 2500 module series, then kindly watch my beginner guide video. You will find the link to that tutorial in the description below. The 1027 step sequencer also has a companion, which is the mixed sequencer module 1050. Today I will be only explaining the 1027 step sequencer because I want you to fully understand how the step sequencer works on its own before combining it with a mixed sequencer module 1050. This will be the topic of another tutorial. If that is something that interests you, then it might be a good time now to subscribe to my YouTube channel if you haven't done so yet. By subscribing, you will stay updated with my latest video uploads and help me grow my channel, enabling my videos to reach a wider audience. Your support would be highly appreciated. And now, let's jump over to the 1027 step sequencer and the Behringer 2600 semi-modular synthesizer. We are looking here at the clocked sequential control module 1027. The 8-position step sequencer from the Behringer 2500 Eurorack module range. If you are new to the 2500 modules, then please watch my beginner video on the 2500 modules. The link is provided in the video description below. Just let me give you a brief description what an analog step sequencer is. An analog step sequencer for a modular synthesizer is a device that sends a series of control signals to a synthesizer module in a predetermined sequence, allowing for the creation of repeating patterns of notes or rhythmic sequences. It typically consists of a row of knobs or sliders that represent each step in the sequence, with each knob or slider corresponding to a specific pitch or control voltage. The sequencer can be programmed by setting the knobs or sliders to the desired positions and thereby producing a specific control voltage, and the sequence can be played back continuously or triggered manually. Also bear in mind that the 1027 step sequencer does not have a quantizer like most contemporary sequencers. For those who don't know it, a quantizer in a music sequencer is a tool that aligns incoming pitches to a musical scale or grid. It ensures that notes played or sequenced are in tune with a selected scale or key. So here on the 1027 step sequencer we have 3 columns with 8 steps: channel A, channel B, channel C. Each step has a maximum control voltage output of 10 volt. I will be using channel A for controlling the pitch of the oscillators of the Behringer 2600. Therefore, each knob or step in channel A has a different position representing a different control voltage and pitch. Channel B will be used for controlling the cutoff frequency of the filter of the Behringer 2600. Here again, every step has a different position representing a different control voltage, resulting in a different filter cutoff frequency on the Behringer 2600. And channel C will also be used to adjust the cutoff frequency of the filter and to modulate the frequency on a VCO on the Behringer 2600. The rate knob here controls the step speed at which the sequencer moves from step to step. It is actually an oscillator outputting a pulse wave. And with the pulse width knob here, we can set the width of the rectangular waveform. More about this later. And now let's connect channel A to the oscillators of the Behringer 2600. If you are not familiar with the Behringer 2600, the ARP 2600 or another 2600 clone, then I encourage you to watch my beginner video series. You can find the link to the playlist in the video description below. So we are going to take here the channel A output on the step sequencer 1027 and plug it here into the multiplier row on the Behringer 2600. So we are doing this because we want to duplicate the signal that we can send the control voltages coming from channel A, that we can send these control voltages to every single VCO here on the Behringer 2600. So we take a cable, plug it here into the multiplier slot, and plug it here into the keyboard CV slot on the Behringer 2600 VCO number 3. We are going to repeat this process with oscillator number 2 and with oscillator number 1. So I press now the start button on the sequencer and bring up initial gain, opening the filter, and now you can hear the sequence playing. I stop the sequence. With this reset button here, I jump back to position number 1, and I can step through the sequence manually by pressing the step button. Okay, I close the filter and bring down initial gain. And the next thing we are going to do is that we send a gate signal from the 1027 step sequencer to the envelope generators of the Behringer 2600. So we take a cable and plug it here into the click output on the 1027 step sequencer. And we run this cable here on the Behringer 2600 into the sample and hold clock slot. Then we have to make sure that we move this switch downward. And when I now start the sequencer, you can hear that the gate signal from the step sequencer is triggering the envelopes. And now, when I change the width of the rectangular waveform, you can hear how we are moving from a short gate to a longer gate. So I move it back to the middle position. I stop the sequence, press the reset button, and jump back to position number 1, step number 1 this is. Okay, so the next step is that we take the channel B output here on the step sequencer, and we use these control voltages of channel B to modulate the cutoff frequency of the filter. So we plug this cable now into the keyboard CV slot here in the filter control section. I start the sequence, and now I move up this slider. And you can hear how the cutoff frequency of the filter is changing with every step. I bring in some reverb here. And play around with the envelopes a little bit. Okay, so the next thing we are going to do is that we take the channel C output, we plug in a cable into the channel C output, and also plug it here into the control section of the 2600 VCF. So, and now I start the sequence again. Now only channel B is controlling the cutoff frequency, and as we bring up this slider, we introduce the control voltages of channel C, and thereby we mix the control voltages of channel B and C. Bringing in some reverb again. We stop the sequence. And now, instead of controlling the cutoff frequency with channel C of the step sequencer, we are going to modulate the frequency of oscillator number 3. So we plug this cable here into the control section of VCO number 3. Let's use here the ADSR slot. I start the sequence and I bring in this slider and the control voltages of channel C. This sounds about right. I add a little bit of delay. Bringing in the noise generator. Okay, I stop the sequence. And now the final thing we are going to do is that we are using the position gates here of the 1027 step sequencer. So with every step, you can output a position gate, and this is a 5-volt output. So we take now an output here, a position gate, of step number 4 and plug it, let's say, into the FM control section of oscillator number 2. So we use here the sample and hold slot. I start the sequence. Now only oscillator number 1 and 2 are playing. And now I bring in the position gate to modulate the pitch of oscillator number 2. So always at step number 4, the pitch of oscillator number 2 is modulated by the control voltage of the gate at step number 4. So all 3 oscillators are playing again. Sounds about right. And the delay again. And now I would like to give you some further information about the oscillator here, which is clocking the 1027 sequencer module. You can also use this oscillator as a sound source. We have here two ranges for the oscillator. A low range, which is running from 0.3 to 15 Hertz. And then when you move it to the high range, it's running from 10 Hertz to 400 Hertz. So at the moment, I have connected an Arturia key step to the Behringer 2600 via MIDI. Here, all three VCOs of the 2600 are going into the mixer section of the filter. And when I now press some keys on the keyboard, you can hear these three oscillators. So we move these sliders down so you won't hear any oscillator from the 2600, and instead we are going to use here the clock output of the 1027 step sequencer and plug it here into the ring modulator slot in the mixer section of the VCF. So I open the filter, I bring up initial gain, and here on the sequencer module 1027 I start the sequencer and I move up the slider here. You can hear now the oscillator of the 1027 sequencer module. Let me change the pitch. And I'm changing the width of the pulse. Okay, I close the filter and bring down initial gain. Now we can also control the pitch of this oscillator running in the 1027 sequencer module. For this we are going to take the pitch output of the Arturia key step and plug it here into the rate slot of the sequencer module. And now, when I now press a key on the keyboard, you can hear some kind of scale. It's not a proper scale, but you can see how the pitch coming from the CV output of the Arturia key step is controlling the pitch of the oscillator which is running in the sequencer module. So now when I bring in also the oscillators of the 2600, let me tune this a little bit. This sounds about right. As I said, it's not a proper scale, but you have an additional fourth oscillator when using this sequencer module as a sound source. What do you think about the 1027 step sequencer? Would that be a module for your Eurorack system? Or do you have one already, and how are you using it? Kindly share your thoughts and your experience with the community here by leaving a comment below. Alright, that's it for today. Thank you so much for watching. I hope to see you again in my next video. Until then, take care, stay safe, peace.